Hi, we're Senior Design Team 14237, and our project objective was to reduce energy use in campus maple syrup processing. Every spring, 10 to 20 million gallons of maple syrup are produced in the US and Canada, a process that requires 400 to 800 million gallons of water to be boiled off from the dilute sugar maple sap. Here at RIT, the maple sugaring class collects 200 to 300 gallons of sap each spring, yielding an average of 6 gallons of maple syrup. Maple syrup producers use carbon-based fuels to boil off excess water. The RIT class uses a propane-fired 3-burner evaporator, burning through nearly 20 tanks of propane each season. Our main project goals were to reduce the emissions and processing time involved in the evaporation process. Our team's solution was to build a small-scale reverse osmosis system, which removes about half of the water from the maple sap before the rest is boiled off in the evaporator. The process begins with a boost pump that draws in maple sap and pressurizes it to about 95 psi. The sap is filtered after collection, but we use a sediment filter in line to prevent any residual debris from entering the system. Next, the sap enters the first reverse osmosis membrane. Under high pressure, the tiny water molecules are forced through the membrane, while the larger molecules in maple syrup are diverted. Pure water flows out of one outlet, while more concentrated sap flows out at the other. The sap then flows into 2 more RO membranes, connected in parallel, to speed the processing rate and further increase concentration. A flow restrictor is needed to provide back pressure and force some water through the membranes. It can be adjusted for the ideal processing rate and sap end concentration. After the second reverse osmosis stage, sap exits at double the original concentration, and the removed pure water exits in another tube. Although we encountered several major issues like air buildup in the RO membranes or the lack of a flow restrictor causing complete system failure, we were able to troubleshoot, brainstorm, and ultimately produce a robust final product. By removing half of the water, everything else is cut in half: boiling time, fuel consumption, and CO2 emissions, meeting all of our project goals. Reverse osmosis technology is widely used for large-scale maple syrup operations to make business more efficient and economical. By providing a miniaturized, portable version of this technology, the system also meets a nice-to-have requirement, serving as a teaching aid. We'd like to thank our client, Tom Connolly, and our guide, John Bonzo, for their support, funding, and consistent interest and involvement in our progress towards this final product.